All right, welcome everyone. First off, let me say thank you everyone for coming to join us in this talk. I'm going to be talking about whether or not your Java workloads could be missing something through the choice of JVM that you're using or JDK that you're using, and talk a little bit about a JDK that maybe you might not be using already or you're already using and could be using more effectively. So that runtime is called IBM Semeru Runtimes. And I just wanted to explain the name because not everyone's heard the story. This picture at the bottom right here, Mount Semeru is the tallest mountain on the island of Java in Indonesia. That's the island that the Java programming language could be named for. But it's also the part of Java that's in the clouds. So I like to say Semeru Runtimes is the Java that's built for the clouds. I work for IBM, so my lawyers like you to read these things. You can check it out in the replay. A little bit about me if you don't know me. I've been working in the area of JIT compilers and JVM building for a very long time, 22 years now professionally. And I didn't study Java in university, but I did spend a lot of time looking at computer architectures and compiler optimization. So I've been doing this a very long time. In particularly relevant for this talk, I was the technical lead for the open source projects that IBM had to contribute our J9 JVM into the Eclipse Foundation. So there's two projects. One is Eclipse OMR, which is actually this one, and Eclipse OpenJ9, which is the one that we'll be focusing on today. I'd love to answer questions about either one of them. If you come to me to chat with me, that'd be great. I was also the technical lead for the creation of Semeru Runtimes, so I kind of know a bit about this stuff. Today, what I'm going to go through is basically a quick refresher on Semeru Runtimes and OpenJ9. Let me actually just pause right here and I'm hoping everyone's heard of OpenJ9 who's in this. Okay, that's pretty good. Even some that haven't, that's great. Okay, welcome. And who is using OpenJ9? That's only a couple hands. All right, cool. People to convert. I like it. All right, so I'm going to talk brief refresher on what Semeru Runtimes and OpenJ9 are, especially for those that haven't heard of them. You'll get a little bit of an introduction there. I'll talk about what OpenJ9 brings to the Java ecosystem in terms of its performance capabilities and so forth. And then I'm going to go through a section on kind of the adoption process as we've seen it from Eclipse OpenJ9 and Semeru Runtimes and look at some of the... That doesn't sound good. Oh, we're back. Good. I don't want to have to do this without slides. The things that have been good about adoption, the things that we've been doing to try to help people use OpenJ9 more effectively, and some of the things that haven't been working so well, and talk about some of those things and what we're trying to do to make them better. And finally, I'll give you a very brief peek at things that are coming later in 2024 as part of the ongoing development of this JDK and the JVM. One of the themes for the talk that I'd like to just emphasize right now is I do want to inform you about things that we've done and that we're doing to improve. I want to give you some tips so that you can get the most out of Semeru and OpenJ9, but really, I don't know the best answers to all of these things. I recognize that. And if you know things or if you've had experiences with this that either haven't gone well or have gone well, I would love to hear about them. So please, please, please do come and talk to me at the conference. I don't bite. I'm not a monster or an ogre. I try to be quite friendly, so I would love to talk to you, anyone, about any of this stuff. All right, so let's jump in. Very quickly, IBM Semeru Runtimes is the Java distribution that we use at IBM. IBM has literally thousands of software products that are based on Java, and they all build on top of Semeru Runtimes as the JDK that they use. It's been used in those products since 2006, so it is a very mature product. It's used across many, many different platforms, including x86 and ARM64, in fact. Some people are confused about that because they think IBM only focuses on IBM platforms. In fact, I would say more of our software runs on x86 than it does on IBM platforms. The Semeru Runtimes have two editions, and the difference is almost irrelevant for you. The license is different between these two editions, and in the certified edition, we have run the TCK certification tests. It is all 100% open source. I like to say the two editions are 100% functionally identical, which is to say we build the same code into both of them. So So they're really interchangeable from the point of view of use. And as I always also mentioned, broad platform support. And this is not just any other OpenJDK distribution. So obviously there are probably a dozen OpenJDK distributions out there. Semeru Runtimes is the only distribution that replaces the JVM with the Eclipse OpenJ9 JVM. And that gives Semeru Runtime a number of performance characteristics that differ from Hotspot. And so that makes Semeru Runtimes unique in the Java industry. What is Eclipse OpenJ9? That is a big wall of text, sorry. You have to see it on a movie screen to realize how bad it is, sorry. So OpenJ9 was originally built in the 90s as an embedded space JDK. It was built to go into things like oscilloscopes and cell phones. And in that space, the devices are very, very, very small. And so OpenJ9 has been architected from the beginning to be very frugal on its use of memory and to organize and architect its use of memory. And that's important for some of the capabilities that have become useful in the cloud. It is a proprietary, or it started off as a proprietary independent implementation of the JVM, so it shares no code with Hotspot. The team that built it is not part of the team that has ever even looked at Hotspot, but it's built to the JVM specifications. And so it can provide a very good implementation of Java to run Java workloads, and but it is completely separate from Hotspot. In about 2016, we started contributing the code in our proprietary JVM called J9 into the Eclipse Foundation as OpenJ9 and OMR, as I mentioned. I'm not going to talk about OMR today, but OpenJ9. And so it's been available ever since then as a Eclipse OpenJ9 is a source code project, but it needs to be built as a JDK, and that's these days that's the IBM Semeru Runtimes. It's available for everyone to use. It's publicly downloadable. There's Docker containers. Actually, I have a slide on this somewhere, I think. So I'll leave it to that. All right, and OpenJ9 is not, oh, actually, sorry, I didn't cover all of that. So there are lots of different things that we've done in OpenJ9 that make it very suitable for cloud workloads. I can't say that we did these things back in the 90s, predicting that the cloud would exist and that memory and startup time would be very important in the cloud, but we were urged to focus by our business on a lot of these performance characteristics very early on. So we've been looking at startup and memory performance in OpenJ9 specifically, or in J9 specifically, since about 2005. We've been investing in that space for quite a long time. And we've done things like trying to architect the memory very carefully. And recently we've been building a number of technologies that are focused on the needs of cloud workloads in terms of optimizing startup and reducing memory footprint. Things like Instant On, which I showed in the keynote yesterday. Our shared class cache is a broad platform support approach to save about half of the startup time in a Java application. Basically, you can store classes and JIT code to disk and reload them in a subsequent run of the JVM so that you don't have to keep rejitting the same things over and over again. We have a single compiler technology called Testarossa, which spans all the uses of compilation that we use with OpenJ9. Hotspot has C1, it has C2, it has Graal, Azul has the Falcon JIT. So all of these are different, completely different compiler technologies. They all operate differently. In contrast, OpenJ9 has this single compilation technology that we use for cached JIT code. We use for adaptive compilation. We can compile methods at cold, warm, hot, very hot, scorching based on how important the method is to the execution time of the program, etc. And the other nice thing about OpenJ9 is it's a single JVM source across all JDK releases. So OpenJ9 releases continuously 6 times a year, and most of those releases, the 4 quarterly releases, release into all the active JDK levels at the same time. So JDK 8, 11, 17, 21, and we're about to release 22 in about a week or so. So it's been a great run with OpenJ9. It has a number of great advantages. This prolonged greater attention to startup and memory use has brought some different performance characteristics, and I wanted to talk about that a little bit. So OpenJ9 takes what I would say is a more balanced approach to the performance of Java workloads. If you look at the many different scenarios where Java workloads run, there's a lot of different metrics that you can look at and that people care about. And everyone cares about metrics differently because it depends on what your workloads are doing. So you can't really afford to focus. If you work in a large team underneath a large number of products, you can't really afford to just focus on raw speed because not everyone cares about raw speed to the degree that you would that you can ignore other metrics. Some people really care about startup. Some people really care about memory footprint. Some people really care about response time. So we've had to take a more balanced approach here. And I wanted to point out that there's this kind of semi-myth that I've heard a couple of times about OpenJ9 that it favors memory and startup over raw speed. And that's not quite true. I would phrase this differently. I would phrase it as we take a more balanced approach that doesn't unduly favor raw speed over memory and startup. We do really care about raw speed. We don't want OpenJ9 to be dog slow. It's just that my performance architect, I was talking with him a couple of weeks ago, and he made this. He came up with this phrase that that last 10% of raw speed might be better spent on other things. So every time you improve one metric, you often see a price in other metrics. So getting that last 10% of raw speed, you might be better off spending that on dramatically improving startup or memory footprint and giving up that 10%. And that's kind of the approach that we take with OpenJ9. Don't go too far in any one direction. So what does that end up producing? So Semeru Runtimes has some sort of common, I'm going to focus on startup and memory again, but but the sort of common rules of thumb for what you would see using Semeru Runtimes on a Java workload that where everything is working well would be that your startup times will be about half of what you would see with another JDK distribution, and the Java workloads will use about half the memory. And so, startup time matters because it can reduce downtime when problems happen. It means faster recovery from events. Events are always happening when if something bad happens and it goes down, it comes back up fast. You can redeploy faster. You can get a new thing up faster. It allows you to be that much more elastically responsive to your workload. You can go up and down very quickly and only pay money for the load when it's there. And all of this is implemented as a fully Java compliant kind of solution. We believe in the Java standards. We want everything to work consistently for all Java, not just a subset of Java. And then from a memory perspective, obviously, if you need more memory, it means you need bigger VMs. Bigger VMs cost more money. I don't know that this is true today, but I did look at one point, and if you look at the cost of VMs on AWS, if you need twice the memory, it was roughly twice the cost. Volker may correct me on that, but it seemed like a basic rule of thumb for the ones that I was looking at. And so if you think about that, you might be able to get 2 smaller VMs for the same cost and get twice the output if your throughput hasn't dropped very much. And that actually might be a better solution than having one single larger VM. It's just a scale out versus scale up argument. And then in these two spaces, we have 2 new technologies that we've been introducing over the last couple of years. One is Instant On the left, which helps, it uses a snapshot restore approach for Java workloads on Linux, where this is the one I demoed in the keynote yesterday. You can basically start up a Java workload, a Java EE workload even, in about 200 milliseconds. So much, much faster startup. And then the cloud compiler is something that uses, it offloads the JIT compilation overheads into another process or another server so that you can, it's kind of a separation of concerns thing. If you have them both in the same JVM, then you have to accommodate the activities of both your application and what the JIT compiler is doing and figure out how do you size your container to make both of those things happy, particularly when you don't probably understand very much what the JIT compiler is doing. But we can separate those concerns out, and you can have just the JVM running your workload and needing resources to run your workload, which presumably you understand better than the JIT compiler. And the JIT compiler, on the other hand, you can collapse all of the JIT compiler workload for all of your JVMs into one place and just give it a bunch of resource and let it go. I'm not going to spend too much time here, but I just wanted to show how shrinking the containers, like making the containers smaller because we've managed to offload all of the memory and CPU requirements of the JIT compiler, can help you with performance. So is this going to work? No, of course not. That'd be too easy. Oh, there we go. So over here, sorry, I don't like using the pointer, but it's the easiest way to get on this screen. This is with 2 cores, with 1 cores, and with 0.5 cores. And you can see the default Semeru runtime showing throughput in operations per second. If you have 2 cores, you can get 4,500. With 1 core, you get basically half that. With 0.5 cores, you get a little over 1,000 here. So it's starting to not scale perfectly. But the line with the cloud compiler is always ramping up faster when it's in this process. So the cloud compiler helps you ramp up quicker even in very small resource containers. And then on the right-hand side, we've got memory. So all the containers here have 2 cores, and I'm reducing the memory from 450 to 400 to 225. And just to exemplify or just to exacerbate the problem, this runs with no swap. So once you get down to a small enough container, eventually something causes the JVM to go out of memory, like you run a JIT compile and it needs a gig of memory, you don't have a gig of memory, and it throws out of memory. In a real scenario where you have some swap, it would handle this very gracefully. So this is not reflective of the performance that you would get from Semeru Runtimes running with the cloud compiler. But it shows the impact of, where is it? There it is. It shows the impact of that memory use. And over time, that can actually cause problems. So, as we shrink, you can see the ramp-up curves as we're shrinking the container size are getting, they're not very great. But with the cloud compiler running, we can actually get down to 225 and have a much nicer ramp-up curve. And obviously, this is the same. You're getting this same curve here with 2 cores. So the cloud compiler helps you ramp up more effectively, even when your container is really, really small, like only 1 CPU, only 225 megs of memory. That's a pretty small container to run an EE benchmark in, and it's handling load, obviously. And I'm not going to spend too much time here because I've probably already spent too much time on this section. The overall performance of these things, we take it very seriously. We look at all of these things at the same time, and it's not rewrite for this presentation. Something I didn't do. What's going on here? Wow. Sorry. Failure, clicker fail. And also presentation fail. So the reason why I included this slide was not to say this, so don't read that. It was more to say that the different technologies that we introduce into Semeru Runtimes are not necessarily meant to be tools that you use in isolation, because they're usually focused on improving one particular aspect of the performance equation. But if you use them together, you can see improvements across the board, right? So Instant On does a really good job of improving startup, but it doesn't do very much for your peak RSS. The cloud compiler, which is the black bar, improves peak RSS very well. So if you're using both Instant On and the cloud compiler, you get low startup, fast startup. You get very low memory use, and you also get the same basic performance throughput. And you can see there's also an improvement in ramp up here. This is kind of the reflection of ramp up. So we're designing these capabilities to be used together so that they're providing that more balanced approach in terms of performance. Where's it used? Well, so as I mentioned, it's used by all IBM products. So last year we did roughly 900 product releases that are based on Semeru Runtimes. And I like this metaphor of the train, like OpenJ9 Semeru Runtimes is the locomotive pulling all of the cars of the Java products. And from a point of view, our breakdown, just based on the public site downloads that we've got, most people are on Java 17 using Semeru Runtimes, but there's still a healthy number of people using 8 and 21, which has already been picked up, even though it was only released in January. These are numbers from the last 6 months, basically. So this is only 4 months worth of downloads. So we're getting a good uptick of Java 21 now. It's available on Docker Hub. It's available at our site. It's available on SDK. You can SDK man with this -sem. It's also a distribution Semeru for setup Java on your GitHub Actions. So it's out there. It's available. It's easy for people to use and to test with. Now, let's see how adoption works for people. So, adopting a JVM can be very easy. For many deployments, switching to Semeru Runtimes is drop-in. It just works. In fact, I would say that's probably true for 90 to 95% of the Java workloads that I've seen. It just works. And that's because OpenJ9 implements the JVM specification. And we're using OpenJDK class libraries, which are the same class libraries that everyone else programs against, because they're really the only class libraries out there. And it's designed to be a drop-in replacement. And most of the times that's successful. However, if you do use some things around the edges and some things that are not specified in the JVM spec or rely on those, then you can hit some issues. So let's see. I did want to make this point about the independence. So sometimes it's really valuable to have an independent implementation because, for example, I don't know if all of you heard there was a problem with macOS 14.4 where all of a sudden Java stopped working on Macs. That actually didn't affect Semeru Runtimes because we don't generate code the same way in Semeru Runtimes and OpenJ9 on that platform as Hotspot does. Everyone else uses Hotspot, so everyone was affected by that except us because it was a separate implementation. So these are the kinds of, that's not going to come up every time, and it's not always going to be in our favor that there's a difference, but it just happened to be that one was in our favor. So mostly when people are adopting OpenJ9, they see it starts faster, it reaches peak throughput faster, it uses less memory, and you can get further improvement with upgrades because we're continually updating Semeru Runtimes, and that's continually feeding into all of the Java releases that people use. I'm not going to claim this is particularly insightful, but I like to think of adoption in terms of the stages that people can be at. And I've explained it this way a couple of times to some of the people on our team to try to get them to start thinking on these lines of sort of where are we in the journey of adopting OpenJ9. It starts off with the people up there in that corner who said they hadn't even heard of OpenJ9 before. That's really a very early stage of adoption of OpenJ9. You don't even know it exists. And then there's the people who know about it, but haven't yet been motivated to try it. I didn't ask if people had tried it. I asked if people had used it before. So I'm not gonna. I don't want to know right now. But I'm sure that there are people who have learned about it, but they haven't necessarily taken the step to try it yet. Then there's the people who've tried it, but they haven't. It doesn't work on their application for some reason. And then there are the people who've run it and it did work. But they haven't even looked to see if it actually made a benefit. They just kind of got to the point of being able to run it. And then you measure it, but they weren't compelling. Or you measured it and they were compelling and it was great. But maybe I'm not willing to support it because it's an extra JVM, it's an extra runtime scenario. I already have so many things that I have to test and so many resources are needed to run those tests. I can't afford to run it all twice because I want to support a JDK with Hotspot and a JDK with OpenJ9. And I'm not willing to commit to OpenJ9 yet. And then finally, there's a person that you get to the point where you actually are committed to running your application on OpenJ9, but you're not singularly dedicated to it yet. And finally, at the end, you decide you only want to run with OpenJ9 because you find the benefits compelling and you don't see any reason to continue using anyone else. I would say there are very few people at that last one, but I'm going to focus in this talk on I don't even know what Semeru Runtimes is. I tried it, but for some reason it doesn't run my application. So, some of those corner cases that I talked about. So let's talk about some of those. And the last one is I've measured the benefits, but they didn't seem compelling to me. So I want to talk through some tips on how to use Semeru Runtimes and try to get the most out of it. So let's start with the first one, increasing awareness. So obviously, lots of people do know. There was a bunch of people in the crowd here who put up their hands. Actually, most of the people in the crowd here put up their hands to say that they knew about OpenJ9, so that's good. We've made some inroads in here. 8 years ago, nobody knew about OpenJ9 because it hadn't been open sourced yet. So it's good that there are people who know about OpenJ9, but I confess I was a little disappointed in the keynote when I asked this question and only about a quarter of the audience knew about OpenJ9. So that's still a problem for us. And I'm really still trying to figure out why. I know some likely reasons. So, for some people, the JDK is just too far down in the stack. It's not interesting enough. It's not. It's just a means to an end. So they don't really think about which one they're using. We've been working on it a long time to try to get people at least to the point of being aware of OpenJ9, and we've focused on what the improvements are that you get with OpenJ9 to try to motivate people to care about it. But I'm not sure that we've been entirely successful here. So this is one of those areas where I would love to hear your feedback and thoughts on maybe why it's not as well known as it could be. I mean, we've been around since 2016, so it's a long time. We've published lots of articles, and I don't know, maybe we're just not finding the right ways to reach out to people. So if you have ideas, I'd love to hear them. Another part of the reason behind this is that we all work for IBM. IBM is the main company behind the building of OpenJ9 and the distribution of IBM Semeru Runtimes. And we do make it available for free for everyone to use. We do have a developer advocacy team that goes out to conferences and talks to people about OpenJ9 and what it's good for and all that sort of stuff. But for IBM, it's not really part of our business. IBM doesn't build Java to make money from it. It's a, I'll use the phrase again, it's a means to an end for us. We have an IBM software business that is based on Java, and we build Semeru Runtimes so that we have a way of supporting that business very efficiently and effectively with a local team, and to invest in things that our business wants, even though they may not be the things that the entire Java ecosystem wants or that the entire Java JVM community wants. So it gives us some freedom of action, but it doesn't actually contribute to the direct revenues of IBM, and so IBM doesn't tend to invest all that much in advocacy because it just doesn't matter to our business. It's not a good enough payback. So that means we don't spend lots of money going out there and talking to lots and lots of people and trying to get the word into everybody's ear. And then finally, I think one of the other ones here is that open source projects, which are obviously the sort of hopeful first adopters of some of the technology, they just don't have the resources to be able to test many variants and to be able to commit to supporting something that not everyone's going to be using, and they can't afford to be able to solve problems on OpenJ9. Even though obviously they could reach out to the OpenJ9 project for help at any time. So this is one of the areas where we're hoping to refocus our advocacy efforts a little bit to try to motivate and help open source projects realize the benefits of OpenJ9, to understand that there are benefits to supporting OpenJ9, and then to see what we can do to help work with them to reduce the overhead costs to the projects to be able to support these things. So, and then I guess finally, I think this is the last one. One of the things that hampered us was we used to be part of this community called Adopt OpenJDK. Adopt OpenJDK was a community that was formed by the London Java community, actually, that Jamocha community, I forget what they really called themselves. But anyway, they produced community binary builds of OpenJDK, and that's really frustrating. And they, just make sure it's not me. Oops. Well, now it goes backwards. Okay. But Adopt OpenJDK, when it migrated to the Eclipse Foundation, found themselves unable to build OpenJDK builds with OpenJ9 anymore because of legal considerations, and so it fell back onto IBM to step forward to be able to build the IBM Semeru Runtimes, and I think that transition hurt us in a way. It was difficult. Not everybody wanted to make the transition from a community-based Adopt OpenJDK to consuming a vendor JDK binary, even though it's freely available for use in production and similarly licensed. And basically, we just did the same thing that the community was doing previously. So, in summary, awareness has improved a lot since we first created OpenJ9, and even since Semeru Runtimes was first created in 2021. But obviously, we'd like it to expand more. I would like to be able to ask in a keynote presentation like yesterday, who's heard of OpenJ9, and have everyone put their hand up. I don't need everybody to be using it, but I would like everyone to have heard of it. So if you have any advice here, I'm not asking you to speak right now, but come talk to me, please, if you have any thoughts or advice on this front, because I'm really interested in making this go better. All right, how am I doing for time? No, not too bad. Okay, so the second adoption path that I'm going to talk about is like, what happens if you try Semeru OpenJ9 and it doesn't run some of your applications, so you run into problems. And I think the biggest problem behind this, or the root cause of this issue, is basically OpenJ9 is an independent implementation of the JVM specification, but the JVM specifications don't really describe all user behavior, and we don't want them to either, right? Like user behavior, like a user visible behavior would include performance, startup time, and and memory footprint use, and all of that stuff. So I don't want that to be specified, because I want the flexibility to be able to increase startup and deliver faster memory footprint. But there are some areas where the specification is a little bit light, and it allows it allows implementation defined behavior. And there are some aspects of Java where the spec just doesn't say anything. And so these are the kinds of areas where we get into sort of issues. So let's go through a few of these. So an example of non-specified stuff. This actually isn't OpenJ9 or Semeru Runtimes specific, but the industry, for a number of reasons, has gone through a bit of a migration trying to get from Oracle JDK 8 to OpenJDK 8. And there are a number of proprietary technologies in Oracle JDK 8 that complicate the migration to OpenJDK 8. So, and we get bundled into this sometimes too, because we're the people who are migrating are sometimes coming from Oracle JDK 8 to get to OpenJDK 8 using Semeru Runtimes, and they encounter all the migration issues associated with that issue. Now, there are lots of documents that can help people get through this migration. Lots of people have gotten through this migration, even with Semeru Runtimes. And there are lots of documents that you can go out and look at. One warning I will put here is to make sure you're aware of the source of the information that you're reading, because sometimes there are other other goals of those articles that are not just to help you migrate from Oracle JDK 8 to OpenJDK 8. All right. Another one which has been causing us some trouble recently is some of the capabilities that are implemented by Hotspot are not implemented by OpenJ9. And one of the big ones here is JFR, the Java Flight Recorder. So there are a number of open source projects that have been starting to build dependencies on the presence of JFR, because it's a great facility. It's very useful for serviceability, debugging problems, and understanding what the JVM is doing and what your Java application is doing at runtime. It was introduced into Hotspot with the JEP 328 in Java 11, I believe it was. And unfortunately, this is one of the Hotspot JEPs that OpenJ9 decided not to implement. One of the unfortunate changes in how the Java community runs in recent years is that we do things via JEPs. And JEPs don't necessarily have specifications associated with them. If you go back 15 years, more of the work used to be done in what were called JSRs, Java Specification Requests. And so there was a lot of focus on building specifications for new functionalities so that different implementations could implement those specifications and get them consistent across different implementations. Now there is less focus on different implementations, and the work happens in JEPs. JEPs are managed differently than JSRs, and there's not as much of a focus on bringing in specifications for new things. That's not universally true, but JFR is an example of something that's a facility that was built into Hotspot that does not have a specification attached to it, and that makes it hard for OpenJ9 to implement, because as an independent implementation, you're not supposed to look at the other thing's code. And so if there's no spec to it, it's much harder to actually build a parallel implementation of something. So JFR has been getting better and better. It's become used in more things now, and things are depending on it. Some of those things are starting to get pulled into IBM products, which makes it a big problem for me. And so we're actually looking at what it's going to take to implement JFR and OpenJ9 right now, so that we can provide a parallel facility that works as closely as possible as we can make it to what Hotspot does here, so that we can continue to have OpenJ9 provide the support that all of the open source projects need, and in particular for our products to use. We're hoping to have something to showcase here by the end of the year, but that's not a promise, and refer back to the lawyer page. A third area here is command line options. So there are a bunch of command line options in Java that are very consistent, because they've been around forever, and we standardized them because they were built at a time when there were multiple implementations, and we wanted those implementations to act the same way, right? So things like setting the size of the maximum size of the heap -xmx, asking for the version of the JVM, specifying that you only want the code to run interpreted and not with the JIT compiler. These options are all standardized across all JVM implementations, and they work on OpenJ9 just as well as they work on Hotspot. However, there's a number of these -xx options which are supposed to be optional, and they end up being very JVM specific. So, performance tuning is the perfect example of this, where if you look at Hotspot's, the great variety of -xx options for tuning GC, for example, there are lots of options there that are very technology specific. They're sizing some buffer or some cache size or something that's inside the implementation of Hotspot. It doesn't make sense to have an option like that in OpenJ9. But if you're using that option and it gives you a performance benefit, then when you move to OpenJ9, it's not necessarily easy to map that over. So we've done one big step here is that OpenJ9 automatically sets ignore unrecognized VM options. This is a way to get Java applications that have been running on Hotspot to very easily move across and at least run on OpenJ9. It's perhaps not the most ideal solution to the problem from the perspective of finding problems, but it helps with the, I tried it and it fell over right away and I walked away. This helps with that problem. And so by setting this unrecognized options, it does run. And in some cases, there are direct equivalents of the options that Hotspot has specified that we can translate to in OpenJ9. For example, if somebody is trying to specifically use the G1 GC in Hotspot, OpenJ9 has a balanced GC policy that you can activate, so we can translate that option into the option that makes sense in OpenJ9, and we do that automatically because we know you want a region-based GC if you're specifically telling Hotspot that you want it. We don't see that option quite as much anymore because obviously it's the default in Hotspot for a long time. But that's an example of an option that directly translates over. And it's not the only one. There's a bunch of them. Given all of that, your Java workloads probably will at least run and get past the command line processing with OpenJ9. But there may be some tuning opportunities, right, that just kind of show off because we've ignored all of the tuning options that you put on your command line. And so you could actually, just as a tip, you could, like, once you get going and you're happy with kind of where you are, if the performance isn't what you think it should be, you can try turning off this ignore unrecognized VM options to find the possible tuning opportunities. Look for options, and then you can try searching in the OpenJ9 docs for things that you can do that are addressing the same kind of problem that you use that tuning option to try to fix. Or you can look at using different OpenJ9 tuning options in the same area of the code, like the GC tuning guide or etc. We've also had to do some things that I really don't like, which is like this, we introduced this fairly recently, this -xx compatibility equals Elasticsearch. I would really prefer not to have to do things like this, but unfortunately there are some open source projects that have taken a very strong stance about not including OpenJ9 in their support statements, to the degree that they won't even accept pull requests that modify their code to make it run on another JVM. And it's not just us that gets affected by this, but we are one of the implementations that they have chosen not to support. So when Elasticsearch starts up, I'm not trying to pick on Elasticsearch, it's just an example I'm very familiar with. When they start up, there's a path in their code that basically verifies that they ask the JVM for what are the active command line options, and they specifically go and look for this option being set. -xx plus use G1 GC, because I think in their case it's also that they don't want to support multiple GC policies in Hotspot, but it also has this effect of kind of locking out OpenJ9 and other JVM implementations. So and it wouldn't be right for OpenJ9 to add this option and say, yes, we're using the G1 GC, because we're not. There is no G1 GC in OpenJ9. So by default, I don't want to turn that option on to be able to support Elasticsearch. And on top of that, there was an attempt to change the code that did this in Elasticsearch that was not successful. It was rejected by the community. And so we introduced this compatibility kind of notion where For those cases where we're just completely unable to upstream the changes that are needed for OpenJ9, we put this. You can add this compatibility option equals Elasticsearch. And if you're running Elasticsearch, it will actually lie and say it's using G1 GC even though it's not, just to get past that check. Lots of people use Elasticsearch with OpenJ9. Lots of people at IBM use Elasticsearch. So it works, and it has the same performance characteristics that OpenJ9 traditionally has. Wow, maybe I need to stop moving this around. But if it can't even start, you can't even use it. So we introduced this to fix it. And I'm way behind here, so I need to speed up. Vendor-specific classes, things like com.sun. This hotspot diagnostics MB. Again, it would be a little bit weird for OpenJ9 to implement a hotspot-specific class in a com.sun package space, but we did it anyway. So this one we got over ourselves and include a bare-bone hotspot diagnostic MX bean, at least so that the cast that people tend to put into their code works, because the class exists and it has the right relationship with the OpenJ9. The OpenJ9 one subclasses it and provides better implementations of things, but there's a base class hotspot MX bean that is there for people to cast to. There are some tools that aren't supported, like that used to be not supported, JCommand, JPS, JMap, JStack, all these useful things. They're there now. We implemented them. So those are there. Caveats about Java micro-benchmarking harness. Internally, it uses a bunch of hotspot-specific options to control inlining for the JIT compiler to try to mimic what it thinks is going to happen at runtime if you were to run this code in a real application. So it kind of tries to fake out the JIT. It knows how to do that for hotspot. It does not know how to do that for OpenJ9. So if you use JMH to compare hotspot and OpenJ9 performance, OpenJ9 is almost certainly going to lose out. We would love to make this work on OpenJ9. Just have to figure out the best way to do this. I'm not 100% sure whether upstream will allow us to make changes for OpenJ9 there, but we're going to be looking into how we would do the equivalent things in OpenJ9 and try to get that working. If upstream won't accept it, we'll probably just include our own JMH that does an OpenJ9 specific version of things, because obviously it's a very useful tool. There's also this Java object layout tool in Project Lilliput, which throws an illegal state exception if it doesn't start on hotspot. This is another one of those packages that is starting to become, other things are becoming dependent on. I was looking at Maven Central. I think there's over 400 projects that depend on JOL core, which pulls this thing in. JOL, I think the main thing they pull it in for is to be able to estimate the size of a Java object instance, from a class. So from a class, you can estimate what its instance size is. And so everyone's pulling in this thing, and it just doesn't work on OpenJ9. We recently had an IBM product that started building on top of one of the even downstream dependencies of it. It wasn't pulling it in directly, it was pulling in a project that pulled it in, and then it just doesn't start on Semeru Runtimes, which is kind of annoying. Environment variables is another place that's challenging. One interesting thing with environment variables is we've defined this OpenJ9 Java options, which is a place where you can put options that are specific to OpenJ9. That helps you be able to run Java workloads on both OpenJ9 and Hotspot if you have both of them operational in your environment. So you can configure things like shared class cache and instant on and cloud compiler using options that Hotspot doesn't understand and would break if it got those command line options. You can put them all on here and be able to coexist with other things. And system properties is the other thing. We got bitten by the Java vendor problem at one point because there are actually multiple IBM. People tend to assume that the vendor equates to what the JVM supports. And there are different kinds of JVMs, like the IBM SDK for Java 8 has a completely different security implementation than OpenJDK. And they assumed that if Java vendor was IBM, that it meant that other security implementation is being used. But all of our Semeru runtimes use the OpenJDK security implementation, so you shouldn't really be overloading those kinds of things. But anyway, things like Java vendor are different. Things like version are the same. We've added a bunch of system properties that are specific to OpenJ9, etc. But sometimes people get mucked up in these because they're looking for specific things and making assumptions about what they mean. So we fixed a lot of these, but there's obviously still more to do. I mean, some of those in my list even are things that we need more to do with. It's not a complete list, I know, but if there are ones here that you think I should know about, again, I would love to hear about them so that just to make sure that we're aware of them and we can track them and try to make progress on them. All right, I am way behind time here. I have 1 minute to do the last, like, I don't even want to know how many slides. Okay, let's go quickly here. Measuring performance benefits isn't always as easy. You can make mistakes configuring OpenJ9, so it can be the configuration side, but it can still be a problem with OpenJ9. How do you tell? And let's look at a few things that can go wrong. So what if you find that your memory use isn't improved? We usually track memory use using RSS, or PSS is even better. And in a containers, you can use things like Podman stats or Docker stats to track how much memory and how much CPU is being used. There are other kinds of telemetry that you can use that will be able to get the resident set size. But one thing that's important, and we've seen this in a few cases, to make sure you're setting the same heap size for both Hotspot and OpenJ9, because they do have different some default heuristics for setting the heap size if you don't set it explicitly. And that can sometimes cause unexplained kind of performance differences in memory use. You should see reductions in memory by to a third to a half. I've seen it as low as using a third of the memory. In fact, I showed that in the workshop I did on Monday, a case where for Tomcat we were using about a third of the memory that Semeru, the Eclipse Semeru release uses. If you don't see very much memory benefit, the most common problem is this, because this is a really common performance tuning advice, right? If you want the fastest speed, set the max heap and the min heap to the same size so that it won't have to grow or shrink the heap. But obviously, if you tell us we need a heap that big, we have no flexibility in making the heap smaller than that. So we can't save memory. Even though you may not need all of that memory, you told us to use it, so we'll use it. But if you take away that -XMS or make that -XMS a smaller number, that gives us more flexibility to be able to reduce the heap size and still provide, within 10% of the performance of, and often, at the same or even greater performance. So this is one tuning thing to really look out for. We've seen that quite a bit. It's also possible that you've already tuned -XMX size to be just about the amount of memory that Hotspot needs. And that would be just about the same amount of memory maybe that OpenJ9 needs too. So that might minimize the amount of work, the amount of savings we can do. This is unlikely. This might be the case where you see less memory savings than you expect. The danger of tuning Hotspot to very close to the size that it actually needs is that well, you might start throwing out of memory because because you're too close to the threshold. Yeah, it's also possible that your heap size doesn't dominate application use. Like if you have tons of off-heap memory use, I can't do anything about that with OpenJ9. It's not being managed. What if the shared class cache doesn't improve time? Most common problem here is that you're measuring, the way the shared class cache works is in the first run, a population run, you create the cache, you store a bunch of stuff in there. The JVM is actually using different heuristics to decide what to compile and how to put it into the cache so that later runs will be fast. So in fact, a cold run is going to be even slower than a default run. And I showed this in the workshop on Monday. So you really want to make sure that you're measuring warm runs and not cold runs. And it's an easy mistake to make, especially in containers, because in a container, basically the cache you build gets thrown away because unless you're careful about it, it's not persisted in the container. And the next time you start the container, you're doing another cold run. And then the container goes away and you build another container and it does another cold run. So there's some advice here on things that you could do differently to pre-populate a cache, store it in the container. I showed how to do this on the workshop on Monday. I'm going to be tweeting out the link to the GitHub repo that has the workshop there. So if you don't follow me on Twitter, it'd be a great idea to do that, and then you'll see that link and you'll be able to take a look at the workshop. Could be full. Here's some tuning advice. I know I'm over time here, so I'm going to just quickly go through this. You might have changed the Java command line after populating the cache. That can invalidate the use of the cache. For example, if you change the GC policy, I have to generate different code. So the code that's in the cache isn't going to be useful. If you change the heap size, that's fine. But if you change the GC policy from, say, GenCon to balanced, that won't work because I need to generate different code, and the code that's in the cache won't be usable. Yes, URL class loader is where it's normally if you use URL class loader, we'll automatically use the shared class cache. If you don't use URL class loader, it won't by default. So there's a lot of there's some stuff here on ways to avoid this. We are trying to make this better by actually instrumenting Javalang class loader rather than URL class loader. If it's slower than expected, this boils down to sometimes not measuring correctly or using. We haven't been focusing on benchmark code for a very long time. We've been focusing on IBM product code, right? Real application use. And that means sometimes we have missed opportunities that benchmarks have, and that makes us look bad. But there's actually some important code paths in benchmarks, so we're discovering that we need to fix some things. So we've been working on that now, and hopefully later this year things will get better. Because of our focus on real application workloads and not on benchmarks, we tend to take a little bit longer to find hotspots and things. So if your application runs or your benchmark runs very quickly, sometimes OpenJ9 comes out looking bad because it just hasn't reached its peak performance yet. This is another thing that we're focusing on fixing. In fact, we've made, I believe, 30% improvement in compilation times, JIT compilation times recently, and that should help a lot with this problem. OSR is something that Hotspot's been doing a lot longer than OpenJ9, so we're still in the process of improving it. We don't rely on OSR as much for our optimization as much as Hotspot does, and it has some pluses and minuses. Minuses are we're just not as good at doing getting performance out of this some of these things, but on the plus side, we don't have things like deop storms because we haven't biased our code too much towards things that aren't compiled into the compiled methods. And also, we might optimize better when the common case isn't heavily biased because we have different optimization approach here. I mentioned JMH already. It helps Hotspot a lot more than it helps OpenJ9, so just be careful about that. And also, just as a common point, it's not uncommon for performance benchmarks to measure something other than what they think they're measuring. So when you get performance problems like this, I would encourage everyone, if you can't understand it yourself, come to the OpenJ9 project, open an issue, talk with us, let us know what's going on. If you can give us the example code, that would be great. I mentioned that there's some option mapping between Hotspot and OpenJ9. This is the sort of major GC policies in Hotspot and how they translate to OpenJ9. We do as many of these automatically as we can, but some of them aren't quite what we don't know what you want to do with serial GC, for example, or use parallel old GC. I don't know how many people are using some of these other GC policies, but this is one way to map across for Hotspot. And yeah, some common things that go wrong. So I've seen this one a number of times. People think, hey, I need compiled code. Let's compile everything before I run my application. And in Java, that's just a really bad idea because a vast majority of the code doesn't run enough to really matter whether you've compiled it or interpreted it, but it takes a lot of time to compile it. So don't do this. And rely more on the JIT heuristics. I would say, if you want to play with the counts, go nuts. But I wouldn't expect to find tremendous, don't start with count equals 0 and expect it to be better. Change more from the existing settings and just see if making it a little bit more or a little bit less helps you if you really want to do this. But I don't really recommend it. AOT and JIT code. So the AOT is the code that gets stored into the shared class cache. Don't expect them to have quite the same performance. There's about a 10% on average delta between these two. And also, you can use this option over here called -xtune virtualize, which we designed for really small container environments. It will more aggressively use AOT code even during ramp up. So you'll need a bigger cache when you use it because it compiles a lot more methods. And then the cloud compiler, yeah, it's good for moving resource consumption over there. It's very easy to use. There's directions on our blog site for how to use it. It's better to stagger the starts of multiple JVMs if you can, so that you don't overload the JIT compiler. But yeah. Sorry, I know I'm way over, but I'll just spend one slide talking about things that we're going to do in the rest of this year. So we're going to continue our advocacy, as I mentioned, and we're trying to focus more on trying to get improve awareness of issues like this. You will still see us around at conferences, so please say hi. Please talk to us. We are going to be working on our highest priority usability gaps and looking into what it takes to implement JFR and other things, and what to do about the Java Object Layout tool and so on. There's a lot of performance improvements that we're hoping to bring over the course of the next few months in OpenJ9. A lot of these should surface as performance improvements on benchmarks, performance improvements on Java workloads, and so hopefully if you're using OpenJ9 or you choose to try out OpenJ9, performance improvements are coming to you regardless of what Java version you're using. And just one more iteration of I'd really love to talk to you about any of this. I apologize for going long in this talk, but these are some ways that you can reach out to me if you need icebreakers. But please do talk. And with that, I'll say thank you. I guess I can take questions if anybody's asked any. We don't have time. Well, there's only one question anyway. How does the cloud compiler work? Yes. So how does the cloud compiler work? Is it like a sidecar container? Is it supported in non-cloud container environment? It works as a separate service. It sets up a separate process. That process can be on another machine. It can be on the same machine. You can set it up as a container alongside another container. It's very easy to configure and use. Come talk to me if you want to learn more about that. It's very easy. And that's the only question I got. Thank you very much for coming. Thank you very much for staying a little bit long. I apologize for taking more time out of your day, but I hope you found it interesting, and come talk to me.